Hello all, welcome to my channel. In this subject of operations research, I will explain BCOM method for solving LPP problem. I have already made a video to explain when we need to use BCOM method. I will share the link in the description. Those who want to go through that video can see the video. So let's start the BCOM method. Here we have a maximization problem which will solve by BCOM method or Charles method or penalty method. The method is called as BCOM or penalty method because we give a huge penalty to a particular variable. That's why it is called as a big M or penalty method. And it is called as Charles method after the name of the inventor Charles. So this problem here is maximize z is equal to 12x1 plus 5x2 subjected to 2x1 plus 3x2 is less than or equal to 40, 3x1 plus 2x2 is less than or equal to 28, x1 plus x2 is greater than or equal to 6, and x1 x2 is are greater than or equal to 0. So the first two constants are less than or equal to type, so we'll add a slack variable in both the cases, s1 and s2. The third constraint is greater than or equal to type, so we'll have to subtract a surplus variable because left hand side is greater than right hand side, so we'll have to subtract something from here. So what we subtract is called as surplus variable, and this is our first step, which will be to convert the given problem into standard form, and the standard form will be like this: subjected to the constraint 2x1 plus 3x3 plus s1 equal to 40, 3x1 plus 2x2 plus s2 equal to 28. The third constraint is x1 plus x2 minus s3 equal to 6. Now if you go with this s1 equal to 40, s2 is equal to 28 and minus s3 is equal to 6 as the initial basic feasible solution, then we will get s3 is equal to minus 6 and the solution will not be feasible. Okay, so we will have to add artificial variable. As I had explained in the video, we will add artificial variable a1 so that our basic variables now will be s1, s2 and a1, and the non-basic variable will be x1, x2 and s3, so that when we put x1, x2 and s3 equal to 0, we get s1 equal to 40, s2 is equal to 28 and a1 equal to 6 as the initial basic feasible solution. So we have added an artificial variable in the given problem. And our initial basic feasible solution, as I have told you, is S1 equal to 40, S2 is equal to 28 and A1 equal to 6. Now look at the objective function. When we convert the given problem into standard form, it becomes maximize z is equal to 12x1 plus 5x2 plus 0s1 plus 0s2 plus 0s3. By now you are familiar with this 0s1, 0s2 and 0s3 as they do not contribute in the objective function. So we'll write the coefficient as 0. What about this a1? A1 is an artificial variable which is given a huge penalty m. So m is a huge number. And this m will either be positive or negative. Now, since this is a maximization sum, this m will be negative. Had it been a positive minimization sum, the m would have been positive. So for maximize, it's minus m. For minimize, it is plus m. Okay, so we'll move to the next step. After adding the artificial variable, our basic tableau will look like this. What we have in this basic tableau, we have x1, x2 as the two decision variables, s1, s2 and s3 as the three slack and surplus variable, and we have artificial variable a1. Now we all remember how to fill this matrix or how to fill this table. How do we fill this table? This 2, 3, 3, 2 and 1, 1 comes from the constant. 2, 3, 3, 2 and 1, 1. It comes from the constant. Then for S1, S2, S3 and A1, this also comes from the constant. So if you can see here, in first equation we have only S1, in second equation we have only S2, in the third equation we have minus S3 and plus A1. So this A1 entry under the head A1 entry here will be 1 and not M or minus M. You have to be careful about this. This 1 comes from this table, this constraint. So this will be 1. And when we write the Cj values or the Cj row, the Cj row is written from the objective function. So we can see here it is minus ma1. So it will be minus m. Also the basis is written from the objective function. So this will also be minus m. So minus m here, and plus 1 here. And this is the solution column 40, 28 and 60. Also one thing can be noted here. The basic variables are S1, S2 and A1. So identity matrix is formed by S1, S2 and A1 only and not by S1, S2 and S3 as usual. Identity matrix is formed by S1, S2 and A1. So you can remember one thing, that identity matrix is always formed by those variables which are in the basic. Which are the variables in the basic? S1, S2 and A1. S1, S2 and A1. So S1 and S2 and A1 only will form the identity matrix. S3 will not be the form of part of the identity matrix. Okay. There may be some question to few people that should we write A1 before S1 or should we write A1 before S3? So it doesn't matter. Wherever you write A1, it doesn't matter. The sequence of this does not matter, but when we copy it from the constraint like 2 and 3, so first we'll write x1, then only we'll write x2. Okay, even if you disturb the sequence of this, you can write s1 here, a1, x1, s2, x2, anything. That won't matter for that. Is it clear? So we'll move to the next thing. Next thing is to find the ZJ value. How do you find ZJ value? ZJ values are found by multiplication of this basics by the x1, x2 and so on column. So here we will get 0 into 2, 0 into 2 is 0, plus 0 into 3 is 0, plus minus 1 m into 1. So minus m into 1 is minus m, and we will get minus m here. Similarly, we will fill all the entries. Those will be like this. Next step is to find Cj minus Zj value. When we find Cj minus Zj value, it will be 12 minus of minus m, so it will be 12 plus m. 5 minus of minus m will be 5 plus m. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus m is minus m. And minus m minus of minus m, that will be minus m plus m, will become 0. So if we see here, which is the largest value here? 12 is the largest value. Why we are seeing for the largest value? Because it is a maximization sum. So this will become the key column. This will become the key column, and it also means that x1 will now enter in the solution. Now x1 will enter in the solution, so someone has to leave the solution. How will we find who will leave the solution? That is decided from the ratio column. And how do we take ratio? Ratio is always taken as solution column divided by the key column. So we'll get here solution column entry is 40 divided by 2 is 20. Similarly, 28 divided by 3 is 9.3 and 6 divided by 1 is 6. And who will leave now? Who will leave the basic? The least value. The least value, that is A1. Now A1 will leave the basis. A1 will leave the basis. So we have A1 as leaving variable and X1 as entering variable, and the intersection of the leaving and entering variable or the key column and key row is called as the key element. So key element here is 1. So if you remember, what is the importance of key element? Key element will always be made 1, and the other entries in the key column will be made 0 in the next iteration. So we'll move on to the next iteration. We see here that A1 is now replaced by X1. Therefore, A1 coefficient, that is minus m, will also be replaced by X1 coefficient, that is 12 from the objective function. And since this entry is 1, we want this as 1. So this row is written as it is. So I have written R3 new is equal to R3 old. Next, we'll change the R2 row. R2 row can be changed as 3 minus 3 into R3 new. So this will be 3 minus 3 into 1 is 3. 3 minus 3 is 0. Similarly, 2 minus 1 into 3 is minus 2 minus 3, that is minus 1, and so on. And in order to make entries in this row, find entries in this row, what will we do? We will say that R1 new equal to R1 old minus 2 times R3 new, and we will get 0 here. So we have obtained 1 0 0 here. Why we have made this 1 0 0? Because x1 is now a basic variable. Now since x1 is a basic variable, it should be the part of identity matrix. So what was the identity matrix earlier? The identity matrix earlier here was S1, S2 and A1. Who is leaving the variable? A1 is leaving the variable. So this entry 1 0 0 should be obtained here from bottom 1 0 0. Okay. Now this entry will be written here in the next table like this. So we have S1, S2 and X1. Which are the basic variables? S1, S2, X1. So under S1 we have this, S2 we have this, and X1 we have this. So S1, S2 and X1 will form the identity matrix. And if we find now ZJ values, the ZJ values are 12, 12, 0, 0 and minus 12. And what is the value of Z? Z is equal to 72. How we got the value of Z as 72? Z is equal to 12 into X1. Do we have value of X1? Yes, value of X1 is 6. So 12 into 6 is 72. So Z is equal to 72. The next step is to find Cj minus Zj value. If you find Cj minus Zj value, we get here that only this entry here is positive. It means that it means that S3 will now enter in the solution. S3 will enter in the solution. So this column is the key column. This column is the key column, and who will leave the solution? That is identified from the ratio. So we'll take ratio. Ratio is taken as solution divided by the key column. So if you divide the solution by key column, here the third entry is negative here. So we'll not compute this. 28 divided by 2 is 14 and 10 divided by 3 is 3.3, which is the least of this. Ignoring the negative value, 3.3 is the least. It means that S2 will now leave the solution. So S2 will leave the solution, S3 will enter the solution, and this 3 will become the key element. The key element will be made 1 and the other 2 elements will be made 0. So that we'll see in the next iteration, that is iteration 2. So you can see here S2 will now be replaced by S3 and its variable, its coefficient is 0. So no change here. How will we get? How will we get 1 here? We'll get 1 here by dividing this entire row by 3. So that what is written here, R2 equal to R2 old divided by 3 is divide this by 3. So we'll get this. You can see that under A1, the entry is not written. There is nothing written. It's blank because we don't need to allow A1 to enter in the solution now. A1 has left the solution, so we are not interested in this. So even you can delete this column. Even you can delete this column while solving the next iterations. Here, this can be deleted. Now next is to make R3 new as 0. So we will perform some operations with respect to the newly formed row, that is R2 new, and we will get 0 here. And same thing we will do with R1 old row. So R1 new equal to, this should be R1 old minus 2 times R2 new. Here it should be R1 old because we are performing some operation on R1 old with respect to R2 new. So we have 0 here. So this has become now 1, 0 and 0. Now this will be the entries in the table here, and that can be written like this. Now if you find value of Z, what do we have? X1? X1 is 28 by 3. So if you put X1 equal to 28 by 3 here, we get Z is equal to 112. Now if you compute Zj and Cj minus Zj, we see that there is no positive entry in the Cj minus Zj row. So all entry under Cj minus Zj are either negative or 0. So, and there is no positive entry. So there is no entering variable. Now since it is the maximization problem, our iteration stops and we have reached the optimum solution. So what is the optimum solution here? The optimum solution is x1 is equal to, optimum solution obtained by x1 is equal to 28 by 3, s3 is equal to 10 by 3 and s1 is equal to 64 by 3. If we substitute the values of x1, x2, s1, s2 and s3 in the objective function, we get z is equal to 112. Okay, so this is there is a correction here. It should be S2 and this should be S3. So we get Z is equal to 112. This is the final optimized value of Z by solving it by BCOM or Charles or penalty method.